Hi everyone, this is James Shore, and today I want to try a little experiment, what it's actually like to do test-driven development. In a lot of cases, when I go do test-driven development with people, they don't really get the flow of it. So that's what this is. I'm going to take a real project, I'm going to develop it over the course of some number of episodes. I'm going to try to make this as real as possible. I'm going to be using Java for this. And what I want to do is, I have a spreadsheet that I use to sort of do long-term prediction for all of my finances. I actually don't know where this is going to go. Other than that basic idea, I figure we'll sort of figure it out as we go. That's how I approach a lot of my projects. So starting out, well, let's make a test. That's always the first thing. Whenever I start a new project, I usually do this, which is just test nothing and make sure the test can fail for all the reasons that you're seeing here, which is that there's always all this setup you have to do when you first start something out. So let's run that. Oh, it fails. Okay, so now let's make it pass. All right, great. Now we're getting somewhere. What do we want to test? I think the first thing I'd like to do is just make a little class that can track a savings account. A savings account is going to have interest, it's going to have taxes, it's going to have things deposited into it, withdrawn from it. This is sort of a really basic idea, but it's a good place to start. So let's go ahead and do that. So to do that, we're going to rename this. Let's just call it a savings account. We'll rename this to savings account test. And let's see, we want to put into this, well, let's just start by depositing and withdrawing. I'm not exactly sure how I want this to work out. Account, savings account. Go, that's there. We'll need one of these classes, savings account. Okay. That of course should work. That of course should work. If we deposit $100 into there, we should assert that the balance is equal to 100. Let's do that. So really simple to start with. I've got a bit of a primitive session forming here already in that I've got this integer in here, and I don't really want that. Note that I'm not using the getter form. That's just a personal quirk of mine. Don't really like it. Okay, so there we go. Failing test. We expected $100, but was 0. We really need to turn this into an actual currency at some point. So now let's make an int for the balance. Start at 0. Balance is going to plus equal amount and return balance. There, that should work. Yes, it does. So that's our deposit test. And you know what? For convenience, let's put the withdrawal in here too. So this is going to be after deposit, expected 100, but was whatever, and then we'll withdraw 50. And assert after withdrawal, we expect 50, but was something. Nice and simple. Create that. Yes, amount. That should fail. It does. Balance minus equals amount. So I'm not going to fix that primitive obsession just yet. It's definitely out there, but I don't think I want to go after it just yet. I'd like to wait and see what the code shows me in terms of what it needs. Primitive obsession, of course, is using an integer here instead of an actual object that references the concept in question. All right, what do we want to do about negative amounts? I think void negative balance is just fine. So we'll create a new savings account. This new savings account, we might want to factor that out. Account dot withdraw 75. Assert equals minus 75 account dot balance. Not sure about this negative thing, but it's going to be fine for now. Okay, so that is the beginnings of a test. This shows the basics.
All right, so we have a simple
put stuff into the account, take stuff out. That's really not the purpose here. The purpose for this project is to do long-term forecasting of personal finances. And although I do have to say I'm not a financial expert, so don't take anything I say here as financial advice, please. Depositing and withdrawing is fine, but I think what we really need to do here is start doing some projections. So what I want to do is create a test that will project out for a year. Now, I haven't actually figured out how I want to do this yet. So let's just play with it a little bit and see what we come up with. So we'll call this next year, and ultimately what we want to do is get something that we can graph. We want to get a chart or a table or a graph that shows from the current time out to age 100, or however many years from now, how much money will be in this account in every single year. Let's start by just making a savings account, new savings account with $10,000 in it, and let's age it a year. Next year, let's actually do something interesting. Let's not make that a stateful operation. Let's make that an immutable object, which means that this will return a new object for the next year. I'm just sort of thinking out loud here, trying to think of some ideas. And let's assume that it's going to be 10% interest, which is fabulous. Which means that next year what we would have would be well, 10,000 times 10% would be 11,000, correct? So let's see, next year balance. Like I said, I'm just sort of playing with these ideas. I don't have a constructor that takes an initial balance just yet, and that doesn't really fit my understanding of how I want the domain to work. So let's deposit $10,000, and we'll need a next year method. Now I could return that, make that a double, but let's make it an int for now. I don't want to make it a double because of rounding errors and floating point problems. I'd actually rather use fixed precision math. There's our balance, 11,000. It's failing because there's no next year. So we're going to want to return a new savings account. That's returning 0. Okay, good. So I want to add the balance times the interest rate divided by 100. That would give us, did not give us the right answer. Why is that? What's the error here? Oh, deposit. And then return the result. I think that will work. I'm not really thrilled with this code, but it's a good start. Oh, and we need to add the current balance. So, times 1 plus all of that. Expected 11,000, but was 10,000. Okay, I'm confused. I did the math wrong, obviously. So, let's do this. 100 plus interest rate. By the way, if it looks like I'm hacking, yeah, I kind of am. That's just sort of the way I work. I keep hacking at it until it works. What am I doing wrong here? So the important thing here in TDD, of course, is to get it to work before you worry too much about how you've written it. So now that we've got that written, we really need to clean this up. There's so much I don't like about it. So do we really want the savings account to return a new savings account for every year? That's an interesting question. That would allow us to do some interesting stuff. Well, let's just play with this a little bit. Let's go ahead and toss in a little main program. that's C++, that's C sharp, I'll use Gremlin, hello. I'm not going to TVD this code because this is actually itself just a little bit of test code. Now let's run that, and there's a hello. So what we could do here is we could say for int I equals 0, minus 60, I equals, so we'll go from now to 60. Let's make our starting account, savings account, savings account. The reason I'm doing this is it's helpful for me to try to get a grasp on what I want to do. This part of the process is the most difficult because I don't really know what I want to do yet. So account.deposit 10,000. So what we're going to do is just see how $10,000 grows over time, assuming it's compounded clearly. So we should be able to see, we'll say system.out.print, we're going to print year 1 has the amount of balance, and then the account balance here. So let's see what happens with that. Well, there's our 60 years of interest. All right. So the reason I wanted to do that was I just wanted to see what it was like to use this interface. I suppose I could have written it as a test, but I actually wanted to play with the output a little bit. Because like I said, what we're going to end up with is a little program that actually is a UI. It's going to output tables of information like this. It will probably graph it. And I wanted to get a sense of how hard it was to work with this. And that's actually pretty straightforward. So let's go ahead and keep it like that for now. I think the next step should be to start getting some taxes in on this. In particular, what I want to model is not so much a normal savings account, but capital gains tax. So as you have money in a stock market and you make capital gains on it, you incur expenses. What I'd like to do today is start out by creating a scratch pad. Normally when I work, I keep a note card of the things I'm doing. I really like this yearly focus, so I want to change savings account to something like savings account year. I also want to put a yearly balance, or approach the year differently. So I want to have an ending balance, perhaps other things. And I also want to do capital gains. Let's start out with a really simple one. We'll just rename this to savings account year to better reflect what's going on. And same thing here. In case you were wondering, the reason I like putting a underscore in front of my test names is because it causes them to all sort to the top. It's just a cheesy little technique. Some people like to put their tests in a different package or a different folder, but I like having them right next to my production code, but not intermixed with them. So I use an underscore to cause them to all sort to the top. All right, so there's our savings account year. Now, one thing that we have here, we have this deposit withdrawal idea, and for long-term projections, I don't really know if that's what we want. I think what we're going to have is some sort of transferring money between accounts. I'm going to add that to the scratch pad. But I'm going to leave it like it is for now. And then the other thing is I think I want to have an ending balance. So if this object, if a savings account year represents 1 year, then the ending balance should be the balance of that account at the end of the year. And that, of course, should match the balance at the account at the beginning of the year. I'm doing this because it matches the way I did it in my spreadsheet, which gives me a nice visualization of what's going on. And in the future, fairly soon, I think, when we put a UI on this, I think I'm going to want to reflect that. I'm going to want to be able to see what's going on inside of each of these accounts so I can review it as I'm looking at my finances. So ending balance should behave fairly similarly to next year. This is going to require some changing some things. So right now we have this idea that a savings account, well, when it was a savings account, we assumed it always started with 0, but now that's a savings account year, I think we want to start it with a particular amount of money in it. And I think we also have to make an assumption about the interest rates that it receives. And there's our primitive obsession again. This is a currency, this is an interest rate. We really need to make classes around that, I think. So we start with 10,000 with an interest rate of 10, which means that I would expect our ending balance to be 11,000. That's sort of describing a direction for this. I'm not sure how that's all going to interact, but I'm going to go ahead and code this up and then refactor. So let's make it factor. We're going to want to reconcile the next year approach with the ending balance approach. Leave a structure here, which of course is going to cause everything else to break. I think we want to get rid of that old constructor. Okay, I'm expecting everything to pass except for ending balance, and it did. Good. So we want to make this pass. Yeah, that primitive obsession is getting really obvious. And here we can see the conflict between the old approach and the new approach, but I'm going to keep it for now. And here, we need to do the exact same calculation that we have here. By the way, the reason it didn't work last time is because of some sort of interaction between floats and integers and rounding and so forth. I'm not going to try to figure that out because that's also a consequence of my primitive obsession. I think this will work. It did. Great. Okay, so now we've got that working. Now we need to figure out what we want to do with next year. And we need to get rid of this stuff here. I think I want to take out the balance and or the deposit and withdrawal. That was sort of a I don't know what to do, let's just get this thing started step. And now that I'm starting to get more of a handle on this, I'm not as interested in it. Of course, that is going to break my next year test. Let's take this out too. We don't care about negative balances right now. We're not going to do transfers at all for a little while. So what I can do then is next year should assert, let's rewrite this. So we're going to say savings account year account equals new. Yes, I realize that I just retyped the exact same line that I already had. I actually do that quite a bit. When I'm thinking, I find that just moving my fingers helps me figure out what I want to do. So we're going to say it starts with 10,000, has an interest rate of 10. The next year's balance, next year's starting balance should equal this year's ending balance. So that does mean that we'll need a starting balance. And we're going to want to assert that the next year ending balance is equal to, or this year's ending balance is equal to next year's starting balance. That reads pretty nicely. And let's move this down here because I think it makes more sense there. Now, it's not working because next year has a parameter. Take that out. Well, this should fail. Oh, for more reasons than one, I don't have a starting balance. Okay, expected 11,000 but was 0. That was kind of a long period of a lot of stuff to do without a passing test, so I think I overstepped my bounds a little bit there. Next time I'll try to take it in smaller steps. Starting balance, you know what, let's put this aside for a moment and write the code for starting balance. And we just want starting balance to directly reflect whatever we tell it. Yes, it's a fail because we just have subcode in there, but we return balance here. That comes up. There we've got our starting balance working. Good. Let's rename this variable here to starting balance. And let's move it up a little bit. Everything's working. Good. Now let's bring this one back in. Oh, it's working now. Interesting. Probably because we're passing in, yeah, we're passing in the interest rate, and that's being saved, and it's just redoing this calculation. But now I think I can change this to say that our new year is going to start with our ending balance. Let's make that really explicit. And our interest rate. Cool beans. Actually, let's set that to 0 because we didn't tell it. We didn't test anything about what our interest rate should be, so I don't want to make any assumptions. Okay, and we'll need to return that. There. Great. Okay, so our tests are passing. This is going to be this year. This year dot ending balance is equal to next year's starting balance. I love it. Okay, now what do we want to do about that interest rate? Now I know from my previous work in the spreadsheet that in the future I want the interest rate to change over time. Basically, the closer you get to retirement, the less your interest rate is going to be because you're going to move into more and more conservative investment strategies. So we can't just assume that next year's interest rate is going to be the same as this year's interest rate. But that's looking ahead a little bit further than I want to do. I am going to use incremental design and architecture on this. And to start with, I want to just keep this really simple. So let's assume that next year's interest rate is going to equal this year's interest rate. It's good enough for now. Well, next year's interest rate equals this year's interest rate. But it does expose what's perhaps a smell here in the design. Yeah, actually, let's not do that. I think that just makes too many assumptions. You know, before we had an interest rate for next year, I think I'm thinking ahead too much. Let's go ahead and do what I said originally. We'll just have next year's interest rate equal this year's interest rate. And we'll fix it as we learn more. Okay, let's create an interest rate method. And it's int. And this is going to be interest rate. This year, this year. Okay, that should work. No, it's not going to work because I've got it hard-coded to 0. But as soon as I put in the interest rate here in the constructor, that should work. All right, I'm going to try to do a bit of cleanup here. So our starting balance, I want to just review and make sure everything's factored up nice and pretty. Next year's starting balance should equal this year's ending balance. Kind of inclined to join these two together, but I'm not going to do that right now. And let's see how this looks. Well, we don't need deposit anymore. We don't need withdrawal, I don't think. Nope. Shouldn't need balance anymore. Our main program is using it. Yeah. So we'll have to kill that. And what is it? Savings here. Oh, right. We'll change that. Sorry, okay, that's it. That's everybody. I'll see you next time. So what I was doing was just doing some cleanup, and I was so rushed at the end of that video, I don't think I did a very good job. One of the things that I did was I was playing around with main, and I just need to delete that. So let's start out by deleting that. Yes, and so this works. Yeah. And I also wanted to take a look at the scratch pad. We fixed that. We've done the ending balance. We have taken out the deposit withdrawal, which is good enough. We do the next year properly. And I don't remember what I meant by get rid of savings account. Oh, that was the constructor, and I'm pretty sure we've done that. Let's just double check. Yeah, and now let's take a look. Is everything clean here? I suppose the interest rate is something that I coded, but I didn't explicitly put a test around. Let's go ahead and do that. So I have duplication in the way I'm creating this savings account. I think I'll go ahead and factor that out. Let's make sure all this works still. Is there anything else I want to clean up? Starting balance, interest rate, next year, and ending balance. Let's go ahead and move this up as well. That's pretty clean. I feel a lot better about this code than I did last time we looked at it, the end of episode 2. Yeah, I think that's pretty good. Well, let's go ahead and factor this out. I could put in a setup block, but I've actually found that having a helper method seems to work better. And the reason for that is that whatever you put in your setup block, you're stuck with. All your tests have to use that setup, whereas this allows you to parameterize if you need to. And actually, let's rename that to new account and just do some quick cleanup here. Okay, now that's all working. I could be more descriptive in my names here, but I don't think I need to just yet. Maybe here I'll say, we'll just say matches constructor and matches constructor and here applies interest rate. And next year's starting balance equals this year's, next year's interest rate equals this year's interest rate. Okay, so what do we have left? Well, capital gains. Okay, everything's nice and clean. So let's go ahead and get the capital gains in there. So how do we want to approach that? Well, let's start with a test.